All right, today we're going to attempt to go through the first couple of sections in chapter or module 3. 3.1 is linear equations. And if you've taken Math 101, hey, this stuff should look familiar to you. And then we're going to go through section 3.2. And 3.2 deals with quadratic equations. Now, as far as the quadratic equations are concerned, if you take in 101, and for what I believe our 101 classes have to offer, some of this stuff should look familiar, like using solving a quadratic equation by factoring, solving a quadratic equation by using the quadratic formula. I believe that was in there. But this solving equation by the completeness square was not in that 101 course. Also, they talk about a discriminant, and that discriminant concept was not in the 101 course. So those would be some of the new things that are in the second part of module 3. All right, but nonetheless, let's look at the first part, and it is solving linear equations. And let me just add a page. All right, so as far as a linear equation is concerned, linear equations, they're mainly written in the form y is equal to mx plus b, and this is what's called a slope-intercept form. Right, now we don't so much deal with the slope-intercept form in this course. We don't graph, we don't find intercepts or anything to that extent, at least for linear equations. But as far as a linear equation is concerned, you have what's called a linear equation in two variables. And it's usually written in this form. Ax plus by is equal to c, right? Where a, b, and c are just numbers, right? So what makes this a linear equation is the fact that we do have variables, and the powers on the variables, and there's only two variables, an x variable and a y variable, and the powers on the variables are raised to no more than the first power. All right. So like in the quadratic section where we see x squares and that sort of thing, those are not linear equations because the exponents are greater than 1. So it's a linear equation because in two variables. First off, we have two variables, and both of those variables are raised to the first power. I'm just looking through the notes here. Okay, so I'm going to go into section 3.1. And I actually want to start with problem number 10, 11, and 12, right? So these problems are a little bit different. They don't actually ask you to solve the equation for a numerical value. Question number 11 says that they want you to solve this for y. 12 said it also wants you to solve it for y, and 13 says solve for L. Okay. So we take a look at problem number 11. we have 4x plus y is equal to 5. 4x plus y is equal to 5, and we want to solve for y. All right, so what does this actually mean? Well, we want to put y on the side of the equation by itself, and we want to put everything else on the opposite side. So as I look at my equation, right, y is located on the left-hand side. There are two terms that are on the same side as the side that contains the variable y. So I want to move the term that's unrelated to y to the opposite side. Whenever you move terms, right, so a term is just a coefficient in a variable. Whenever you move terms across an equal sign, you mainly will just change the sign. Right? That's called transposing. So if I take this 4x, and if I transpose or move it to the other side, its sign changes from positive to negative. So if I move 4x to the other side, I have y is equal to negative 4x plus 5, and we basically solved it for y. If we look at problem number 12, we're given 7x plus 5y is equal to 35. 7x plus 5y is equal to 35. And again, we want to solve for y. Right? So I'm going to do the same exact thing. So the difference for this problem is y has a coefficient. So remember that a coefficient is just the numerical part of a term. We're asked to solve for y, not for 5y. But the first thing I want to do is just locate the side in which y is located, right? That's the left-hand side. On that side, there are two terms, 7x and 5y. I'm going to take the term that's unrelated to y, which is the 7x, and I'm going to transpose it or move it to the other side. So when I transpose 7x, I now have 5y is equal to negative 7x plus 35. I want to solve it for y, not for 5y. So the opposite of multiplying y by 5 is to divide by 5. So my next step is to divide by 5. All right, so if I divide the left-hand side by 5, the 5's cancel. And if I divide the right-hand side by 5, I get negative 7x plus 35 divided by 5. Now, there is something called the divide by a monomial. Because I haven't actually entered this into the computer, but just based on looking at the answer, right, they have it written a little bit different. So from this point, I'm going to use, let's close that down. I'm going to use this formula. It's called divide by a monomial. So a monomial is just a polynomial with one term. So the formula says if you have a plus b over c, you can treat the denominator as a denominator of every term in the numerator. So I can write this as a over c plus b over c. So if I apply that to this problem, on the left-hand side we have y. That's equal to negative 7/5 x plus 35 over 5. So reducing that 35 over 5 is negative 7/5 x plus 7. So here we don't actually get a numerical value. We're just simply isolating, in this case, for y. We're solving for y. Problem number 13 is similar, right? You're asked to solve for L. Okay, so you would transpose to W and divide by 2. So those 3 problems, well, I guess it's 4 problems. All right, number 4 is also solving for a variable. All right. Now the rest of the problems that precede that, they ask you to solve the equation, right, for a numerical value. So here are the 6 steps to solve a linear equation. The very first step is to remove fractions. So that's the first step. We're going to see some equations that have fractions. The very first thing we want to do is just take out the fraction. We remove the fraction by multiplying both sides by the least common denominator, or the least common multiple. So let me put that stipulation in. I believe my pen just went dead. All right, so that's the least common denominator or the least common multiple. And we'll talk about what that is. The second step is to remove any parentheses. And you're going to remove parentheses by using the distributive property. All right. The third step is to combine like terms on both sides of the equation. So just remember that an equation is anything that contains an equal sign. The fourth thing you want to do is use the addition or the subtraction property of equality. Right? So that just means whatever you do to one side, whatever you add or subtract to one side, you must add or subtract the same thing to the other side. This is sort of like the same thing as transposing. Right? Just simply moving terms across the equal sign, you're going to change their sign. The fifth step is to use the multiplication / division property of equality. So again, whatever you multiply and divide by one side, you multiply and divide the same side by that same quantity to maintain equality. And then the sixth step, which is optional, is to check. All right, so these are the 6 steps we're going to use to solve linear equations. All right, let's look at the very first problem. It says 4x plus 4 is equal to 8. Four x plus 4 is equal to 8. All right, so I'm just going to apply those 6 steps. So the first step says remove any fractions, which we don't have. The second step says remove any parentheses, which we don't have. The third step says to combine like terms on both sides. So if I look on my left-hand side, I can't add these two because they're not like terms. And then on the right-hand side, it's simplified. I simply have 8. So the fourth step says to use the addition or subtraction property of equality. Now in this case, since I want to solve for x, sort of like what we did with the solving for y-type equations, I'm going to take this 4 and I'm going to transpose it to the other side. So that's actually going to be the same thing as subtracting 4 from both sides. Right, so I have 4x plus 4 minus 4 is equal to 8 minus 4. So on the left-hand side, the 4's are going to cancel. I'm going to put 4x. And then 8 minus 4 is 4. Now I could have got the same thing if I would have simply just took positive 4 and transposed it. Right, if I would have moved it to the right-hand side, it would become negative 4, and 8 minus 4 is 4. All right, so transposing can actually save a step. I want to solve for x, not for 4x. So the opposite of multiplying x by 4 is to divide by 4. So we're going to divide both sides by 4. So on the left-hand side, the x is canceled, and 4 over 4 is 1. All right, so we get x equal to 1. Now you can also check these. So I just kind of check this first one. In order to check, you have to use your original equation. So 4x plus 4 is equal to 8. And I'm going to substitute x for 1. And if 1 is a solution, it's going to make both sides equal the same value. So if I were to substitute x for 1, so I have 4 times 1 plus 4 is equal to 8. 4 plus 4 is equal to 8. 8 is equal to 8. Right? So I know that 1 is a solution. Now, as you go through the problems, the difficulty level kind of rises. Let's take a look at number 4. And we got like a lot of parentheses in number 4. So number 4 is, and I have it written down right here, negative 2 times the quantity 3 plus x plus 3 times the quantity x plus 2 is equal to 2 times the quantity x plus 2. All right, so we have a good set of parentheses. All right, so if we go through the steps, I'm not going to use step 1 because there's no fractions, but I am going to use step 2 to remove the parentheses. Now that distributive property looks something like this. It says that A times the quantity B plus C, that equals to AB plus AC. We're going to distribute or multiply that quantity on the outside with everything on the inside of the parentheses. So if we take this first set of parentheses, we're going to distribute negative 2. So negative 2 times 3 is negative 6. Remember your signs, right? A negative times a positive is a negative, and then a negative times a negative is a positive. Negative 2 times x is negative 2x. Next, I'm going to distribute 3 within that next set of parentheses. So 3 times x is 3x. 3 times 2 is 6. I'm going to bring down my equal sign. And now I'm going to distribute 2 on that right-hand side. So 2 times x is 2x, and 2 times 2 is 4. So that was the second step. We have cleared the equation of any parenthesis. Right. The next step says combine like terms on both sides. So remember, a like term is the same variable raised to the same power. So if I look on the left-hand side, I have 2 constants, and that should be a plus 6. All right, so negative 6 plus 6 is going to be 0. And then I have 2 variables, right? I have negative 2x and I have 3x. All right, so I'm going to keep that like variable, which is x. And if I combine my coefficients, negative 2 plus 3 will give me 1. So that left-hand side simplifies down to simply give me x. And I can't combine any like terms on the right-hand side. So I'm going to bring down 2x plus 4. Now notice I have x's on both sides of my equation. Normally we put the x on the left-hand side, but technically it doesn't matter which side of the equation your variable is on. It can either be on the left-hand side or the right-hand side. You normally want to put your variable on the side in which it's positive. So for this one, since I have an x on the left-hand side and a 2x on the right-hand side, I could do one of 2 things. I could either transpose x, right? I can move it to the right-hand side, or I can transpose 2x. So in this case, I'm going to transpose 2x, which means I'm going to subtract 2x from both sides. So I'm going to subtract 2x on the left-hand side. And in order to maintain equality, I'm going to subtract 2x on the right-hand side. If I simplify my left-hand side, x minus 2x, that should give me negative x. And on the right-hand side, the 2 x's will cancel, and that's going to leave me 4. You always want to solve it for a positive variable. So I want to solve it for x, not for negative x. So the opposite of multiplying x by negative 1 is to divide by negative 1. So I'm going to divide both sides by negative 1. So on the left-hand side, a negative divided by a negative makes a positive. And on the right-hand side, a positive divided by a negative is a negative. So we have x is equal to negative 4. So here again, you can check your answer. You just simply substitute negative 4 into that original equation. All right, now let's take a look at one that has a fraction. For example, number 5. Number 5 says solve the equation x minus 1 over 5 plus x over 4 is equal to 7. X minus 1 over 5 plus x over 4 is equal to 7. All Right? So in this case, we have a fraction. We have two fractions. So the first step says in order to get rid of your fractions, you got to multiply both sides by the least common denominator or the least common multiple. Now, for our purposes, we're going to be using this least common multiple concept. So what is a multiple? Well, now everything has a denominator, even this 7, right? That 7 has an understood denominator of 1. So we don't consider anything, any term that doesn't have a denominator. So here are the multiples. So if I look at my first denominator is 5. So the multiples would be 5 times 1, which is 5, 5 times 2, which is 10, 5 times 3, which is 15, and so on and so forth. So the multiples of 5 are 5, 10, 15, 20, 25, and 30. And that'll like keep on going. The multiples of 4, right, that's 4 times 1, 4 times 2, so on and so forth. We have 4, 8, 12, 16, and then we have 20, 24. That's going to keep on going. Now, we may have quite a few numbers that are going to match, but we want the least common multiple. So the smallest number that are multiple to both of these things is 20. So we're going to multiply both sides of the equation by 20. So we're going to multiply the left-hand side by 20. And the right-hand side by 20. So now we kind of introduce a set of parentheses. So when we simplify on the left-hand side, we're going to distribute 20. So I'm distributing 20 with both of these terms. So now if we look at the first term, 20 times x minus 1 over 5, the 20 and the 5, right, 20 divided by 5, that reduces to give us 4, right? So I actually want to distribute 4 with my first term. And let's see, can I change the color? So I actually want to distribute 4 with this first term. So 4 times x is 4x, and 4 times negative 1 is negative 4. Right, so again, I'm distributing 20, but that 20 divided by 5 reduces to a 4, a whole number 4, and then I distribute 4 with my numerator. So that's 4x minus 4. For the second term, remember that I'm distributing 20, not 4. So when I distribute 20 with the second term, that 20 divided by 4, that reduces to a 5. And that's supposed to be blue. But I want to distribute 5 with my second term. So 5 times x should be 5x. Right, so notice that when we distribute 20, it reduces with the denominators. And if I multiply 20 times 7, I get 140. Right, so we have removed the fraction, and we've removed the parentheses. So now we're actually on that third step, and the third step says combine like terms on both sides. So if I look on my left-hand side, I have 2 x variables, So 4x plus 5x is 9x. I'm going to bring down minus 4. And I'm going to bring down my right-hand side, which is 140. Right. I've already combined like terms, so now I want to take this negative 4 and I want to transpose or move it to the right-hand side. So I want to add 4 to both sides. So I have 9x is equal to 144. I want to solve for x, not for 9x. So the opposite of multiplying x by 9 is to divide by 9. So we're going to divide both sides by 9. On the right-hand side, the 9's will cancel. I'm left with x. And 144 divided by 9, I believe, is 16. So x is equal to 16. So whenever you have a fraction, the first thing you should do is determine the least common multiple. Multiply that multiple by both sides, and that should automatically cut any fractions that you have. And then we just proceeded with the steps for the 6 steps. All right, any questions so far? All right, if we scroll down a little bit further, I think all of those are okay. We did those. Okay, 15 through 19, they look like they're word problems. So remember we talked about simple interest, and 15, I think the last two are kind of based on that simple interest concept. So let's take a look at number 15. 15 says find the simple interest earned if $7,000 were invested at a rate of 6% annually for 5 years. Now we did talk about two interest formulas. There was a simple interest formula, which was I equal to P times R times T. And there was a compound interest formula. Now this particular problem asks for simple interest. So we're going to use that I equal to PRT. Let me just paste this into OneNote. All right, so we're asked to find the simple interest earned if $7,000 is invested at a rate of 6% annually for 5 years. So I is equal to P times R times T. P is 7,000. R is 6%. But we got to change that to a decimal to 0.06. Right, just drop the percent symbol. Move that decimal 2 places to the left. And the time, which has to be in years, is 5. Right, so I'm going to multiply all of this stuff together. So that's 7,000 times 6% times 5. So that's 7,000 times 6% times 5, and we get 2,100. But keep in mind that is only the interest that is earned. Or in this case, yeah, the interest that's earned. Right, that would be $22,100. So now that doesn't give you the amount that's going to be in the account after 5 years. So like if you wanted the amount of money that's going to be in your account, you'd have to take the $7,000, which you originally deposited. You would add to that the interest that you earned, and in your account you would have $9,100. Now the last two problems, they kind of play on that fact. So for example, number 18. Number 18 says an amount of $10,000 is borrowed and repaid 6 years later with simple interest. The amount repaid was $14,200. You're asked to find the interest rate, the simple interest rate. So I'm going to copy this into OneNote. All right. So we have to find R. So we have I is equal to P times R times T. What would be the interest? Now it says the amount of $10,000 was borrowed. The amount repaid was $14,200. So the interest that the account earned is going to be that $14,200 minus the $10,000 you originally borrowed. So I is going to equal to 14,200 minus 10,000. So if you were to subtract those two, you get $4,200, right? Because you originally borrowed $10,000, but you had to pay back $14,200, which means that you had to pay that interest of $4,200, right? So that's going to be the interest. The principal is going to be $10,000, right? Because that's the amount of money that you originally borrowed. T is going to be 6 years, and we have to find R. Right? So we're basically going to set up an equation to find R. So for this simple interest, I'm going to substitute in the interest, which was $4,200. That's equal to P. The principal was 10,000 times R, which we don't know, times T, which is 6. So if I kind of use those 6 steps, I don't have any fractions. I don't have any, well, I guess I do have parentheses. Right? Parentheses actually mean to multiply. So I'm going to simplify the right-hand side. So I have 4,200 is equal to 60,000 times R. I want to solve for R. So the opposite of multiplying R by 60,000 is to divide by 60,000. So 4,200 divided by 60,000 is equal to R. And if we divide that up, we get 0.07. And if we change 0.07 to a percent, we have a 7% interest rate. All right, so problem number 18 and problem number 19 are the same. The only difference is in 19 you have to find the time, and it's much similar to problem 18 where we had to find the interest rate. All right, so that is that's section 3.1. All right, now in section 3.2, we deal with quadratic equations. And so what makes a quadratic equation a quadratic equation? Well, here is the standard form for a quadratic equation, and it's ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers. Are real numbers. Okay. The only variables are x squared and x. So since one of the variables is raised to the second power, this is what makes it a quadratic equation. Now, in order to solve a quadratic equation, methods to solve a quadratic equation, we have the factor and zero factor method. Well, factor and zero factor property method. Right, so this is the first, when you're asked to solve an equation, if they're not actually telling you which method they want you to use, this is where you should look first. The factor and zero factor property method. The second method is some called the square root property. Okay, we're going to take a look at all of these. The third method you can use to solve a quadratic equation is completing the square. Although that's very rarely used. And the fourth method is the quadratic formula. You can and the quadratic formula is the most powerful method. So when I say the most powerful, you can use a quadratic formula to solve any quadratic equation. You can only use the factor and zero factor property if you can factor it. Every quadratic equation can't be factored. That doesn't mean it doesn't have an answer. That just means you can't factor it. In order to use the square root property, you need a certain form of your equation to use the square root property. To complete the square, you need a certain form in order to use that method to solve a quadratic equation. But the quadratic formula can be used no matter what your setup is. So it's, in my case, the most powerful method to use. And irregardless of what the directions tell you, you can always use a quadratic formula. So if the question says factor. And if you can't quite factor it, you can use the quadratic formula, you're going to get the same answer. If it wants you to complete the square, if you can't complete the square, you can always use a quadratic formula. Okay, so the quadratic formula is like the most powerful thing you can use to solve a quadratic. All right, so let's take a look at these four methods. So the first method is to factor and use that zero factor property. So we're going to take, well, we'll take the first one. It says x squared minus 81 is equal to 0. X squared minus 81 is equal to 0. Now, normally when you factor, you would preferably look at a trinomial. A trinomial is just a polynomial with 3 terms. Here we have a binomial. And there's a special formula you can use to factor this. And it's the difference of squares. And the formula looks something like this. A squared minus b squared, that's equal to a plus b times a minus b. So if your problem fits this condition, then you can factor by using this formula. So that means that the first term would have to be a perfect square. The last term would have to be a perfect square. And there has to be a minus between the two. So it says if our equation fits this condition, then you can take a plus b, but notice I'm not giving a, I'm giving a squared, but I can find a, plus b. I'm not giving b, I'm giving b squared, but I can find b, times a minus b. So if I write it like this, right, because x squared is x squared minus 9 squared is 81. So by doing this, I pull out an a and I pull out a b. So I can factor that by using that formula. So x squared minus 81 is x plus 9 times x minus 9. So now my equation looks like this. X plus 9 times x minus 9 is equal to 0. In order to solve any linear equation, your equation must be in standard form. And the only thing standard form means is that your equation must be set equal to 0. So we factored the left-hand side. It was set equal to 0. Now we're going to use the zero factor property. And this is the zero factor property. The zero factor property says a times b is equal to 0, or if a times b is equal to 0, then you can let a equal to 0 and b equal to 0. Right? So in my case, x plus 9, that's sort of like a. X minus 9, that's my b, right? And they're being multiplied, what I said in parentheses, equal to 0. So that means I can set a equal to 0 or x plus 9 equal to 0. And I can set b, which is x minus 9 equal to 0. So now I have linear equations versus quadratic equations. So now I can easily solve these for x. So for this first equation, x plus 9 equal to 0, I'm going to transpose 9. So I get x is equal to negative 9. And for that second equation, if I transpose negative 9, I simply move the negative 9 across the equal sign, it becomes positive. So I have x is equal to 9. So those are my two solutions, negative 9 and positive 9. So the first one, you had to use a difference of squares formula. All right, so let's take a look at number 2. All right, number 2 says you solve the quadratic equation by factoring. X squared plus 7x minus 35. X squared minus 7x x squared plus 2x minus 35. And this is problem number 2. And we're going to solve it by factoring. Okay. Now, and it's equal to 0. Now, when you factor, the factoring and the FOIL method are opposite operations. So when I factor this trinomial, I'm first going to make 2 sets of parentheses. Right? This is what you always want to do when you're asked to factor, especially a trinomial. Whatever I put in the set of parentheses as my first term, I must be able to multiply together and get the first term in my trinomial. Right? So x times x is going to give me x squared. Right? So that's the first thing. Whatever you put in your first set of parentheses, you must be able to multiply to get whatever this first term is in your trinomial. The next thing you have to do is determine the signs. So here is the setup. Okay, you have x squared plus bx plus c and I'm going to explain this in just a second. I know I'm writing this fast. So I really don't want you to write this. You can, but I wrote this kind of fast. But it's a pattern to how you determine the signs. And this is how you determine or read that pattern. So notice if you're trying to factor a trinomial, if your third term or your last term is positive, both of those numbers are going to have the same sign as that middle term. So notice if your last term is positive, that means you're going to have both of those numbers that you choose are going to have the same sign as the middle term. So notice both of these terms are positive. the second setup, my last term is positive, my middle term is negative, so that means both of the numbers I'm using in my factorization are going to be negative. If your last term is negative, it doesn't matter what the sign of your middle term is. One of those numbers is always going to be positive, and one of those numbers is always going to be negative. So if we look back at our problem, our last term is negative. So it doesn't matter what the sign of that middle term is, one of those numbers is positive and one of those numbers is negative. So once you make your two sets of parentheses, determine what should go into the front of your parentheses. Keep in mind that they should multiply to give you the first term in your trinomial. So that's the F in the FOIL method. The next thing you do is determine your signs. So in this case, our last term was negative. So that means that one of the numbers is positive, one of the numbers is negative. Now we're going to use what's called the product sum. So the product that's going to equal to C. The sum is going to equal to B. Well, so now what is B and what is C? If we go back to the standard form, B is going to be the coefficient of the middle term. C is going to be that last term. So I need two numbers. When I multiply, I get negative 35. But when I add them together, I get positive 2. But keep in mind, one of those numbers got to be negative, one of those numbers got to be positive. So how do I determine that? Well, I'm going to go back to this last term, right? Because both of the numbers have to multiply to give me negative 35, and then they both have to add up to give me 2. And I'm going to look at all the factors of 35. I can get 35 by multiplying a 1 and a 35. Or I can get 35 by multiplying a 5 times 7, right? So I think I'm going to use, and this is like a trial and error type method. I'm going to use the 5 and the 7. Since my middle term is positive, I'm going to make the 7 positive and the 5 negative, right? Because 7 times negative 5 is negative 35, and 7 plus negative 5 is positive 2. All right, so I know my two numbers are positive 7 and negative 5. So now here's where that FOIL method comes in. So you have the first term, whatever you put for your last terms must give you the last term in your trinomial, right? 7 times negative 5 is negative 35. You get this middle term by taking the outermost. So x times negative 5 is negative 5x. And you take the innermost. 7 times x is 7x. And if you combine those, it should give you that middle term if you have factored it correctly. So that's 2x. So the factoring and the FOIL method are reverse processes. So now that I have the correct factorization, right, x plus 7 times x minus 5 is equal to 0. I'm going to use that 0 factor property. So I'm going to set x plus 7 equal to 0 and x minus 5 equal to 0. And I'm going to solve. So to solve x plus 7 equal to 0, I can transpose that 7. And then when I move it across the equal sign, I get negative 7. And I can transpose negative 5. When I move negative 5 across the equal sign, it becomes positive 5. So my two solutions are negative 7 and positive 5. And that is the factor zero factor property method. There is also, I'm just going to jump to the quadratic formula. And then when we meet again, I will talk about the completing the square, and that's very rarely used. And then we'll take a look at something that's called the discriminant. Okay. And then let's got a couple of word problems. So let's look at the quadratic equation. For example, number 9. It says solve the quadratic equation, use a quadratic formula. So notice this is a problem where you can't factor it. Well, I guess you can factor it. Because you can find two numbers and multiply to give you negative 7. But when you add them, you get 6. Right? You can use a positive 7 and a negative 1. But for whatever reason, it wants us to use a quadratic formula. X squared plus 7x minus 7. And x squared plus 6x minus 7. And this is number 9. Use the quadratic formula. Okay. So now in order to use any of these, well, I shouldn't say any of these methods, but in order to factor and solve, factor and zero factor, you need to put it in standard form. Also, to use a quadratic equation, your quadratic must be in standard form. So here is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So remember, a, b, and c are nothing more than the coefficients or the numerical parts of our trinomial. So a is going to equal to 1, right? A will be the coefficient of the squared term. B is going to equal to 6, right? 6 is the coefficient of the middle term. And C is going to equal to negative 7. Make sure you keep your coefficient as well as your sign. So I'm simply going to dump these numbers into the quadratic formula and simplify. So x is equal to negative 6, right? Because in that formula, it's negative b, and we're substituting b with 6. Plus or minus, now this plus or minus separates out our two answers toward the end. The square root of b squared, so that's 6 squared, minus 4 times a, which is 1, times c, which is negative 7, all over 2 times a, which is 1. So now we're going to simplify what's inside of that square root. So x is equal to -6 plus or minus. So now inside of that square root, you want to use the order operations that please excuse my dear Aunt Sally. You want to do what's in the innermost parentheses first. So here I don't have an innermost parentheses. This set of parentheses is telling me that my base is 6, my exponent is 2. These parentheses are just telling me to multiply. Next, you want to evaluate your exponent. So I'm going to evaluate this exponent. 6 squared is 36. So I'm going to just put an extra step in. I'm going to bring everything else down just to show how this works. So I've simplified my exponents. The next thing you want to do is multiply and divide, right? Please excuse my. So I want to multiply and divide whatever comes first from left to right. So I have -6 plus the square root of 36. So now when you multiply, -4 times 1 gives me a -4. -4 times -7 gives me a positive 28. And that's all divided by 2. So the last thing on that order operations is please excuse my dear Aunt Sally. So A is for add and subtract whatever comes first from left to right. So now I'm going to add within my square root. So x is equal to -6 plus or minus 36 plus 28 should be 64 over 2. The square root of 64 should be 8. So I have -6 plus or minus 8 over 2. Now this plus or minus is going to separate out our two answers. So x is going to equal to -6 plus 8 over 2 and -6 minus 8 over 2. Right, so now I want to simplify my numerator, simplify the denominator, and then divide. So if we look at this first solution, -6 plus 8 is positive 2 over 2. If we look at the second solution, -6 minus 8 is -14 over 2. And now I'm going to simplify. So x is equal to 1 and -7.